All right. Hi, I'm Titus. I was a software development engineer and test for several years before joining SAUCELABS. I've been at SAUCELABS now for 3.5 years. And at SAUCELABS, I get to work with people on their code, work with customers to make sure that how they're interacting with us is optimized for our platform. Take a look at ways that they can make frameworks better, do a lot of training and things like that. It's really a great job. And then I've also been very active in the open source community. So I'm one of the core contributors to Selenium, currently the project lead for Water, which is a test library based on Selenium. And then I'm also part of the browser tools working group for W3C, which essentially is helping define what WebDriver is. And or the WebDriver specification. I'll talk about that a little bit more in a second. And just as an aside, when we were talking about food, we had a W3C conference in Lyon a couple years ago. And as soon as I got there, I got sick. And so I couldn't eat anything.
That's terrible.
The entire time I was in Lyon until the last night. And it was slight torture.
We'll have to send you back.
Yeah, one of these days I'll get back there. But yeah, it was the last night. The meal was one of the best meals of my life, though. So that's something. All right, so let's start with an overview of what Selenium is. And just as a quick, this is the Selenium 101. So I'm keeping things somewhat basic, and I'm going to kind of give some background and history that if we were doing a 201 or an advanced course, I'd be skipping over some of this stuff and digging deeper into things. So there should still be useful information here for more advanced Selenium users, but don't get too bothered if I'm going to cover some basic things. So Selenium is a monorepo, which means that we're storing everything in one GitHub repo. There are 4 major components of what's stored in the Selenium monorepo. There's the Selenium server, and this has multiple nodes. You can run it standalone, or you can run it in a grid with hub and node settings. What most people think of when they hear Selenium is they think the client libraries with the various language bindings. Talk about those more in a second. Selenium IDE. I'm not sure if that's still in the code. Like, it was a Firefox extension for quite a while, and then Mozilla removed the ability to run it, and then we had a new version of Selenium IDE come in, and I know that Applitools was working on that and looking to change it, but I think Microsoft is taking it over to help out with that. So there's still development on that, and that's a record and playback tool, which I'm not going to get too deep into it, but it's not my favorite thing for building out large-scale test suites. And so if you're just looking to automate something or mess around or kind of figure things out, it can be useful. But as far as building something that's maintainable, it's not, that approach to doing testing and writing test code is not what I would recommend. And then the 4th thing that's part of it is the browser drivers themselves. Early on, at one point, all of the different browser drivers were part of the Selenium repository. And then as part of the W3C process, we convinced all of the browser vendors to join the Selenium team in defining what the underlying interaction between the drivers and the browsers and the code should all look like. So the only thing that's left in the Selenium code right now is Internet Explorer, and that's because Microsoft has been focused on Edge, and they took a look at the work that Jim Evans had done for years on Internet Explorer and said, oh, wow, this is amazing. We can't do this much better, so we're just going to let you keep working on this. And so that's the only driver that's still left as part of the Selenium code. All right, so Selenium is often mistaken for a testing tool. It's not actually a testing tool. And there's a lot of confusion in the industry as far as when you should use Selenium and when you shouldn't, and what it's good at and what it isn't good at. Think of Selenium as a robot or a browser automation tool. It's sending low-level commands to and from the browser in the most accurate user-focused, user-emulating way. It does not have the extra layer that testers need in order to synchronize the code, in order to do some of the things that are intended by testers, even if it's essentially a very do what I say instead of a do what I mean kind of a tool. And so it doesn't use that test logic. It doesn't have the extra things. That's one of the things that in my work in Ruby, as far as water, we put a lot of that extra test logic into that library and make it easier to locate things, make it easier to synchronize things, make it easier to abstract things out and encapsulate different behaviors for different elements, et cetera, et cetera. And so pretty much the Selenium community, the Selenium team wants to focus on just being a browser automation tool. And so we expect the users of Selenium to be able to build out that extra code or to use a library that includes that. And those libraries include things like Capybara or Water or WebDriver IO, provide some extra test logic. And there's a number of different things in the Java community. So Selenium doesn't do a great job accounting for the test logic. It doesn't do a great job interacting with the operating system. And so things like downloads or basic authentication, and there's various different things that integrate into the operating system itself that just from a browser-focused tool, it can't do as well. And then performance evaluation, there's a lot of variables that go into monitoring performance, and Selenium is usually not the best way to emulate load to evaluate performance. Okay. So yeah, so just my basic definition of libraries that provide a specific API to implement the W3C WebDriver protocol, enabling users, and this is the important part, to really emulate what the user is actually doing with the browser. And there are alternatives to Selenium out there right now, and they're gaining a lot of popularity because they are doing that extra test logic. They're providing access to some of those things out of the box. And that's obviously important and necessary, but also realize that a lot of the underlying interactions with the browser, they take more shortcuts. The W3C specification that the browser vendors and the Selenium team has put together is by far the most accurate way, most representative of how a user would actually interact with the browser. All right, some quick history here. Selenium was created in 2004 by Jason Huggins at ThoughtWorks. He was working on some accounting software, I think, and he's putting that together and he's trying to figure out the right way to test it. And so he built this JavaScript-based HTML table runner that would emulate a user in order to verify that everything was working. And the story goes that when he presented it, everyone was just like, yeah, whatever on that accounting software, talk about this testing tool. And a number of people in the QA world, as soon as they saw that, it was like, yes, this is going to be a big thing. Let's figure out how to make this better. And because it's not good enough just to run on the same machine, run Selenium on the same machine as the browser, Selenium RC was created in order to be able to send commands remotely to a server on another machine and have that interact with the browser specifically. Selenium IDE, which I already talked about, came along about the same time. Took another couple years for the grid, so you have an actual hub node configuration to come along. I believe that it was Google developers that were working on that. I know Simon Stewart around 2007. I know he had WebDriver was fully was being developed by 2007. He had a product. Selenium developers looked at what WebDriver was doing and said, wow, this is a much better way to interact with a browser. There are certain limitations that the original Selenium design had with cross-site scripting issues and some other things that JavaScript itself just isn't well equipped to handle, that WebDriver removed the need for that. And WebDriver essentially is, let's send just generic HTTP commands to a shim, a little server that's then going to be able to interact with the browser at a lower level so that it's not going to run into just UI specific limitations. So Simon, and I like to joke that Simon is somewhat pathological about backward compatibility. So you see that it took several years there for Simon to create WebDriver in a way that you could still run your old Selenium code and it would translate as best it could to WebDriver backed code. And then we thought it was going to be really quick and easy to get to Selenium 3, but a number of factors made that take 5 years, and that was essentially pulling out all of the legacy code. And so it was just the WebDriver approach and no more RC or Selenium 1 code inside the code base. And the approach that Selenium takes, as we were building up the W3C specification, Selenium 3 slowly added the latest implementation that was being codified in those meetings and in the working group. And Selenium 3.141.59 that we have now completely supports the released production version of WebDriver specification. Selenium 4, which has been in active development for a couple years now, is essentially looking to remove all of the JSON wire protocol, which was the legacy standard for WebDriver, and replace it so that everything is going to be WebDriver W3C standard. And I'll show what that looks like here in a second. Okay, so when you're working with Selenium, there are bindings in pretty much every language that's out there. Like someone has written something in their spare time for the fun of it in all the crazy languages out there. But the 5 that are officially supported by the Selenium project and are part of the monorepo, Ruby, C#, Java, Python, and JavaScript. Now, my preference, obviously, coming from a Ruby background, is to write tests in strong dynamic languages. And that's essentially Ruby and Python, which give you a lot of flexibility to do a lot of different things in a quick and easy fashion. Now, C# and Java provide a lot more protection and structure around what you're doing. And that comes at the cost of having to build out a lot of extra overhead. And I've seen some Java code that people write, and it's just very complicated very quickly, which makes it ironically more difficult to maintain than a lot of Ruby code or Python code, where you have more flexibility with what you're doing and how you change things. Then JavaScript is the one that's kind of different from all the others. It's the less object-oriented approach. JavaScript in Selenium right now has not been well maintained. The person that was writing it moved on to other things, and it was in his spare time he was working on it. And so there are some current limitations. We're definitely looking for people who might be interested in contributing to the Selenium-backed JavaScript. Bindings, it's one of the reasons why. So like both Nightwatch and WebDriver.io and a number of other testing frameworks that are based on the WebDriver protocol have essentially implemented their own low-level bindings rather than using Selenium directly, for good or for bad. So another thing, the browsers, these are the primarily supported browsers. And the key thing to keep in mind here is that they all are trying to implement the W3C specification as best they can, but not all of them are exactly the same. And one of the reasons why W3C, why we wanted to standardize on this, is there were different behaviors for the same actions between the different browsers. And it was really hard to know which of these is right. And so people would end up having, if Firefox, do this, if Internet Explorer, do this other thing. And that got really difficult. And so in the W3C specification world, if something is behaving, if 2 browsers are behaving differently, one of them is wrong, and you can file a bug and ask for that to be fixed. I think a great example of this is alert handling. So by default in Firefox, if you called to see if an alert was there, it would raise an exception. Like you tried to interact with the alert, it would try to interact with something other than the alert, it would raise an exception and then close the alert, where Chrome, it wouldn't. And so it was difficult to check to see if an alert was there because the behaviors were different. So this is the WebDriver Herald website that Jim Evans put together. It hasn't been updated in quite a while, but the concept here is kind of the same. We want to take a look at this pass rate column, and you can see that Internet Explorer and the Chrome underlying Chromium have really high adoption rate for the W3C support. Firefox is also up there. And the thing to pay attention here is that Safari is significantly lower. And some of these failures are going to be kind of the obscure things that very few people are actually going to use day to day in their testing. But it's important to realize that there are going to be some things that are going to fail in Safari that have nothing to do with the code you've written, because the driver itself does not know how to communicate those commands to the browser the same way that other browser vendors have implemented. And it's a frustration in general right now. Apple's has someone dedicated to work on it, and he's overwhelmed with a lot of other things. So it's just kind of where things are right now. Okay, so let's take a look at what Selenium is doing under the hood. So Selenium is essentially a translation library between the pretty code that you're writing in whatever your desired language is, and converting that to JSON blobs that get sent to endpoints. So this line of Ruby code here, where we're initializing a driver, a Chrome driver specifically, what that does is it is sending a post command to a session endpoint on the 9515 port for localhost. And 9515 is the default port number for the Chrome driver. And note that it's sending both desired capabilities, which is the old JSON wire protocol approach. And if you look on if you keep going there, it's got a capabilities with a first match here. So this is considered handshake code. Essentially, Selenium 3 is sending both desired capabilities and capabilities, both the old and the new formats, and essentially letting the endpoint decide what it recognizes, and then will parse the results. So in this case, Chrome driver is recognizing the W3C standard, and it's coming back with a value of capabilities. And then so all of these things that are after that are specific W3C supported results. So what this looks like here, the big picture, so this is just a local execution, and we're showing a couple examples of different browsers, is you have your code on the left, it's in Java, you're using some kind of framework or some kind of libraries that are all, in this case, Java. And then that's run through the Selenium library, which is translating that Java into the JSON, which is getting sent to the driver. And then the driver is communicating with the browser in some proprietary fashion. Each browser vendor figures out the right communication between the driver and the browser to do the things that best represent how a user would do it. So you could also put a standalone server in there, so even on the local machine, and realize that everything from the Selenium code to the driver is always passed around with JSON. So it goes JSON to the server and then JSON to the driver. And then when you're doing a remote execution, so this is a grid setup or a SAUCELABS setup, Selenium is translating it to JSON, and then the hub is sending it to a node, which is sending it to the driver. And all of that gets sent by JSON, and then you have the proprietary to the browser itself. So big picture, this is kind of what's going on with Selenium. And last slide in this section, I always throw up, we've got a new website, selenium.dev. I always throw up this slide just to think about, it is a community. Selenium is written by volunteers. No one is getting paid to write Selenium code. And so there's lots of help that people can provide with documentation or answering questions or contributing in some fashion, finding bugs, reproducing other people's bugs, all sorts of assistance that can be provided that is welcomed. And it's a very welcoming community in general. Most of the core contributors are active in the Slack channel and things like that, or the IRC, which is mirrored with the Slack channel. So something to keep in mind. Before I get to this next section, I'm supposed to ask for more questions from audience. Let me see if there's anything in the group chat. Right, yeah, people talk about the differences between Safari and the other browsers. Absolutely. So I guess another thing that I should point out about Selenium 4 is we are really hoping to have a beta version of Selenium 4 out soon. And we never make promises about anything as far as time frame, but we're close to having everything that we feel is necessary for Selenium 4. There's going to be some pretty major overhauls in some other portions of the code that's going to be really useful. All right. So let's walk through a basic Selenium test. We've got this sauce demo site, SAUCELABS, and we're just going to authenticate ourselves with this page. So there's 7 parts of this. We have to open a browser. We have to navigate where we want to interact with an app. We need to synchronize the state of the code and the site, locate the element you need to interact with, perform the actions on the element. Number 6 is the one a lot of people overlook when they're talking about Selenium scripts. It's not a test if you're not making some kind of assertion. I think one of my favorite stories is when my boss at his last company, he ran their test suite overnight. They run it every night. And one night, the entire site went down. The whole staging environment went down. So they ran their full suite of tests against the staging environment that was not up. 37 of their tests still passed. And so what are they testing? Is it possible for it to fail? No. Were there assertions there that obviously weren't correct? Make sure that you have the right assertions that can fail, and that's essential to it being a test. And then you want to close the browser at the end. So we're just going to run through the code here. Open the browser by initializing a driver in some fashion. You're going to navigate with a get method or a navigate.to method. We need some kind of synchronization here. We want to make sure that the element can be interacted with. Selenium has 2 different things. It can locate an element that's in the DOM, or it can make sure that that element is displayed to the user. And so this code here for checking for the visibility, it's trying to make sure that a user can actually see that. And this is especially important for single page apps when you can have a bunch of code in the DOM, but only some things are interactable from the user standpoint. Now, another thing to keep in mind that's interesting when it comes to the W3C standard is that there was lots of argumentation about how to approach visibility when it comes to working with the driver and the browser. Arguably, evaluating whether an element is visible is the reason you use Selenium for evaluating things. There are other HTML parsers and XML parsers that can give you a lot of information, but that doesn't ensure that there's a visibility. So it was impossible for the people in the room to figure out how to come up with standardized language that we could put into a specification to say whether an element is displayed on the page or not. I think David Burns has a talk from the Selenium conference in London a few years ago talking about a number of the different problems that go into determining whether something is displayed on the page. So what we have is we have this huge JavaScript blob, this atom that we run through a whole bunch of different possible ways that an element might not be displayed, and we smush all that together. It's only 45 kilobytes. And so because it's not part of the W3C to have displayed, we don't necessarily have a displayed endpoint we can't assume that there's a displayed endpoint. And so part of Selenium 4, part of the W3C compatible portions of Selenium 3, we have to take that 45 kilobyte file and send it to the execute script endpoint instead of calling a displayed endpoint directly. So that's one limitation every time you call is displayed that you might keep in mind. So we're making sure that the element is in a state we can use. We put that element into a variable that we can work with, and then we take an action on it. We'll click the button. Then we'll make an assertion and say whatever it is. Make sure that the current URL matches whatever we expect. And then closing the browser is a driver.quit. So the full example of just clicking on a button is this. And this isn't even authentication. This is just clicking on the button, just to show what all goes into a Selenium test. All right, so that's great and all, but it's not really what you do in the real world. So let's start with figuring out how do you just run a test locally. One of the things that you have to deal with when you're running locally is the driver. The browser version and the driver version have to be managed together. And so Selenium is going to be looking for a driver it can work with. One way that you can do this is to add the location of where you've downloaded the driver and put that in the path environment variable in your operating system. So this is, the bash profile, or in the Windows 10 UI, whatever operating system you're working on. That's one way to do it. Selenium will look for the driver in all of those locations. The next thing you can do is you can specify the location of the driver in the code. So here's some Java code that's setting the property to where the driver, where Selenium should look for the driver specifically. The problem is that neither of these actually take into account the fact that the driver version and the browser version need to match. When I was spending a lot of time in the forums helping people with their Selenium code, we'd often get people come in and say, my Chrome tests all of a sudden started failing. What's going on? And I'm like, well, all right, what's the browser version? They're like, oh, it automatically updates, so it's the latest Chrome. Like, what version of Chrome driver? And it's like, oh, it's this version. I'm like, yes, that's from 2 years ago. You need to update that. So one solution is to use some kind of driver manager, which will manage this for you and try to make sure that it's getting the latest and correct version of the driver. Now, you don't have to worry about this at all when you're using a service like SAUCELABS, and this is one of the reasons why a number of people have moved to SAUCELABS, is because trying to manage the driver versions and the browser versions and making sure that they're updated in sync is not necessarily trivial. So your user settings, you get your username and your access key. I've blanked out my access key so you don't steal all of my sessions. This is the code that we used to recommend people use when setting capabilities to initialize their driver. So this is the old JSON wire protocol approach, where you create a capabilities instance and then you're just setting capability for all of these things. Note that lines 3 through 5 there are the standard things that are included in Selenium itself. And then lines 6 through 9 are SAUCELABS specific things. So those are things that SAUCELABS looks at to handle what we do that are independent of the driver itself. So the problem with this is that the W3C specifies only these key values are allowed to be set directly in that top level. And so we have to specify browser name instead of browser version instead of version, and you can't put those SAUCELABS specific things directly in the top level. What we do instead is we have to create this sauce options key. And that's you can look at line 19 and see that's what we're doing. So we create this sauce ops capabilities, and in Java we have to use this new mutable capabilities. And so lines 2 through 8, we're setting all of the values into the mutable capabilities that go into sauce options. Chrome options there are the browser-specific things that's a Selenium class that's being used. And then we're just merging all of these W3C supported values and then the Chrome supported values and then the SAUCE supported values. So it's either one of those, it's either one of these things or it is some browser vendor : keyword that's allowed. So you've got Goog : options or Moz : options or SAUCE : options. That's what's allowed in here. And so you have to make changes to your code, which is a little frustrating for SAUCELABS users to be able to use the latest version and make sure that you are able to interact with the latest browsers in the correct way. There was a huge change to how element actions behave going from the old JSON wire protocol to the W3C approach. And so if you're not using W3C compliant session initialization code, you're not going to be able to interact with elements the way that you were able to do before. Now, realize that the reason this is because Selenium is trying to bend over backward to be backward compatible and guess what you probably want with a lot of things. And there's some really ugly, complicated code that goes into that. And SAUCELABS has decided that we really need our users to tell us what they want, because it is much worse for us to guess and guess wrong than for you to change what you're doing and let us know. So a couple things here. To get those specific values, we've got this platform configurator on our wiki, and you specify the W3C API, you specify the device and operating system and browser version, and then it'll spit out the code that you need to use at the bottom there. And we've got that in all 5 of the primarily supported languages. So this is the main W3C Selenium specific. And you notice at the bottom there, there's a SAUCE options that's essentially an empty capabilities instance. And that lets us know that you are intentionally want a W3C compliant session. So
hey, Titus?
Yeah.
So just to kind of interject for a second, there's a couple of questions in the text chat there on Zoom. And if it's a good moment to take a break, do we want to address those real quick? So I can just read them to you if you want. The first one is, can you recommend a resource for learning Ruby for someone who is already familiar with writing Selenium tests in Java?
Well, so in Ruby, I recommend everyone that is using Selenium. If you're using Ruby Selenium, you either use Capybara or Water, or you reinvent the wheel. And so I recommend, especially if you're using Rails, Capybara is a great choice. Thomas Walpole's put a lot of energy into making that a really robust solution, but it's a very different philosophical approach to what Water does. I think Water is an excellent way to do synchronization on top of Selenium. And so I would take a look at either the Capybara documentation or the Water documentation for working with Ruby specifically. And if you've got any questions on that, be sure to message me and I can talk at length on that.
Perfect. Thanks. And then the next question, and hopefully I won't butcher this one, but can you review Pylenium?
I have seen that Pylenium exists. I don't know a lot about it, in all honesty. I know that I believe one of my colleagues took a little bit more in-depth look at it. Someone tweeted it and I looked at it and I don't remember the details on it. I did ask if they had if they were going to include a driver manager with it, and I believe they said that they were going to add that, and they did. But I haven't, so no, I can't be much helpful about that right now, but we can discuss that later if that's of interest.
Great. Thank you very much.
All right. Great. Okay. So we've got the code for the platform configurator. The next thing we want to pay attention to is the SAUCELABS specific functionality. We've got all of those things that I said you can add. Well, we have this page for test configuration options that lists everything that SAUCELABS recognizes. And we have Chrome-specific things, Selenium-specific things, Appium-specific things, real device-specific things, but everything that you might be interested in specifying that affects the SAUCELABS session can be found here. Now, because we know that writing W3C, converting your code to get a W3C compliant syntax and a session is difficult, we've created this, this code for sauce bindings. We've created this in Java, C#, Ruby, and Python. And essentially, it allows you to specify everything, and we are going to create the W3C compliant syntax for you. So you don't need to figure out what sauce options are, what goes where. It's going to look like this. So the first 2 lines, that's a Selenium class. We're not going to reinvent the wheel and rewrite everything that Google is doing or Mozilla is doing. You get the Chrome options. You can fill out the Chrome specific methods there, add arguments, add prefs, whatever that needs to look like. Then you'll pass that in to the sauce options instance to get a sauce options instance. And then we allow everything that can be set with either the platform configurator or the test configuration. We have specific setters and getters for working with those things. And note that we also have enums. So essentially, you can do sauceplatform.mac high Sierra without having to know that the right string is lowercase mac, uppercase os, space 10.13. You just have that available from your IDE directly. So anyway, take a look at we've got a website for that. Take a look at that. We've put a lot of work into that, but we're still trying to get additional adoption for it. And if you've got any questions or any run into any problems, be sure to let us know. But this should be the easiest way to get your code from where it's at to a W3C, or if you're starting out from scratch, this is by far the best way to start working with SAUCELABS. All right, and this is just an example of what the SAUCELABS dashboard looks like when you're running tests. And you can just see that we specify all of the different browser and operating system tests per each execution. All right. All right, I see a quick question about the biggest impact change we can expect with Selenium 4. Everything, all of the functionality in Selenium 4 exists in Selenium 3, with the exception of we've added some additional locators. There's a bunch of extra things with the grid. It's a different build system. So a lot of the stuff is not going to be user-facing directly. The issue with Selenium 4 is that it won't recognize the JSON wire protocol syntax. And so if you're trying to use Selenium 4, but you're sending SAUCELABS a session that looks like JSON wire protocol to us, you're going to have collisions. And so the latest version, all of the drivers right now are defaulting to W3C. And so really the important thing for being able to upgrade and for being able to use the latest functionality of the drivers, like the actions class for elements, like all of those things, is upgrading the capabilities that you're sending to SAUCELABS. So it's there can be things that you are intending to do with the code you're sending us that does not happen the way you want it to, because we're giving you back a JSON wire protocol instance rather than the W3C instance. So hopefully people understand the document object model, which is essentially when you take a look at inspect an element on a page, it'll show you the elements, and whenever you're working with an element, you're trying to find a unique way to identify the specific element that you're trying to work with. There's usually attribute key value pairs, tag names. Selenium essentially gives you 8 ways to locate elements. IDs are usually good. Name can often be good in a form, unless it's like radio buttons where the names are all the same for all the radio buttons to group them. Usually not unique are things like class name or tag name. I don't recommend using the text of an element to locate it, because it is typically more brittle than other ways to locate it. And so the big thing with using locators is when a standard change or when the developers make a change to the page or the site, does that break the location elements the way that you've located the element? Will your tests start failing? And so when we talk about brittle, that means a change is made. It could have been expected or foreseen, but it causes your test to break because the element's no longer valid and that test is never going to pass again. Sometimes the text might be less brittle than the attribute key value pairs, especially if you're using class names, and that comes into whenever a site redesign happens and they change a class name or they change what goes into that, then that could cause your tests to break in a brittle fashion. And so part of it's the context for the site that you're writing, but usually using some kind of attribute key value is better than using text. And so pretty much everyone eventually has to use either CSS or XPath. And I'll talk about that here in a second. First thing is locating elements is just code that shows how to find element by the different locator types, and then kind of an example of using the find elements. Like I said, class name and tag name usually aren't unique, but you can get a list of all of the elements that match that on the page, and then use the get. It essentially comes back with an array, so you get whichever index value you want from that array. So quick discussion of CSS versus XPath. There are two things that XPath can do that CSS cannot. XPath will allow you to traverse the DOM up and to the left, whereas CSS only allows you down and to the right. And so sometimes it is easier to locate an element by finding something that is a sub-element. Sub-element's got an ID, so let's get that, and then let's go up to the grandparent or whatever. Shouldn't happen. It's not typical, but sometimes that's the least brittle way of locating something. The other thing XPath can do that CSS can't is it can locate any element by text or partial text. Remember, Selenium by default allows you to locate links by text or partial text. XPath will let you do that for any element, a div, a span, a button, anything. The problem with XPath is that it is not very readable. To write good XPath, it's hard to parse it and understand. And unfortunately, most people that use XPath will right-click and inspect and copy the XPath, and it'll be this huge, long, complicated, very brittle, hard-coded. If anything on the page changes, it's going to break value. I have done a lot of work with XPath. XPath is great for working with the driver itself. It's not very easy to work with for humans. And the other big thing that CSS allows you is being able to work with your front-end developers a lot more. All front-end developers have spent a lot of time with CSS locators, understand them, can help work with you on those things, whereas very few developers have heard of XPath, let alone know how to work with it. So yeah, we can have a longer conversation about XPath. A lot of people are like, oh, XPath is evil. It's like, well, I don't think it's evil, but I don't think it should be your first choice. I think having something that is easier to read and more straightforward to work with and is more commonly understood vastly outweighs any benefit that you might get from XPath. All right, let us dig into working with elements. Essentially, there's a bunch of different elements you can get, or a bunch of different information that you can get from elements. These are all the different things that are available. Some of them are Boolean, a true-false response, and some of them are size, dimension values, or just strings that represent the values for specific attribute keys. There are only a handful of actions that you can take on an element. You can click, you can send keys, or you can clear. JSON Wire Protocol had a special endpoint for submit, to submit a form. W3C no longer has that, and so using the submit method in the latest version of Selenium is another one of those JavaScript atoms that gets sent to the execute endpoint. In general, I recommend having code that clicks the submit button rather than using the submit method going forward. So advanced element actions, there's a whole actions class. This is the one that's changed significantly in W3C. The JSON wire protocol was kind of hacked together with a bunch of different things and has issues with the way that it's extensible. Everyone came together and thought about what is the best way to formulate an actions interaction API, and they got that working with for Selenium. With the W3C portion of Selenium 4 will support this. And so that's where you get into the specific keyboard interactions or mouse movements, mouse keys, things like that. And you've got ability to add pens or touchscreen or things like that. It's extensible in that fashion. And then just different browser things. Note that different information in a 201 course, I'd go through all of these things. Essentially information you can get, navigation, interacting with different windows and pop-ups or tabs, moving into and out of frames is special. Essentially, you think of an iframe as like a separate browsing context, a separate, like a different tab as a browsing context, the same way that a subframe is a different browser context. Another common thing is when someone's like, I've right-clicked into this page and I see this ID, but Selenium can't find it. First question is always, does your page use iframes? In fact, this was so common that in Water, if with an element wasn't found, we would throw in a message saying, check to see if your site is using iframes if it errored out on that. JavaScript execution, I've talked about this a little bit, but you can send any JavaScript command that will get run in the browser if it's sent to the execute script endpoint. Working with cookies, which is obviously useful for setting state or validating state. Uploading, downloading files. Uploading is much more useful than downloading. Usually if you're trying to download a file, there's a better way to do what you want to do, and that's a longer conversation. And then alerts, like any of the JavaScript prompts that come up, working with those things. Then the last bit is the real world usage. This is like what I spend all my time in like the advanced Selenium courses, is how are you actually using Selenium in your code to test things the right way, the way that you want. And all of this comes from a framework. It's an overloaded term. I make it a very broad definition of like all of the software that you're using, all of the different libraries and tools that come together to help you run your UI tests. And I make it broad just because I want everyone to realize that all frameworks have different strengths and weaknesses. And so whenever I talk about, here's some suggestions for how to reduce maintenance costs with your framework, some of them are going to be more useful in the context of the framework you have, and some of them won't be. And just recognizing that most of the things I say aren't necessarily best practices as much as they are, here's ideas that I have come across that I have seen be more useful than alternatives. And so, yes, I could probably do half an hour to an hour on each of these assertions on actions, initializing the setup and the teardown, abstracting test data, which is essential, especially for running in parallel, managing your configuration data well, page objects, making sure that you've got some kind of global synchronization strategy. There's lots of really interesting ways to take a look at that. That's one of the key things when I'm evaluating someone's code, and especially for performance, is how do we tweak the synchronization and how do we make that better? Then the wrappers and helpers, this is like a browser wrapper or element wrappers, being able to encapsulate specific behaviors. There's no reason to send keys to a span element most of the time. And then API shortcuts. And just to touch on this, I see a lot of testers that don't know what APIs the developers have made accessible to public. If you don't have to open a browser to test that a feature is working correctly, I strongly suggest you find ways to test it without going through the browser. And APIs are a great way to set up state and to validate the results of actions taken in the UI. And just understanding what things can be done. So I need an address to edit. I can use an API to create that address on the fly rather than either grabbing something that's already there or spending a lot of time filling out, locating, and sending information on each value. It's one call to the API rather than dozens of calls in the UI. All right, so that's what I have. I could go into more detail on most of those things, but I'm going to spare people for that. Let's take a look at what questions we might have. I think I saw a few things in here. All right. We have latest Angular version based on single page apps. Are we talking about Protractor specifically or just working with Angular backends? Just any single page app? We'll come back to that one in a second. Using text can be troubling, specifically when testing sites that contain multiple languages. Yes, absolutely. In fact, that's a point I usually make, and it's a great one to be reminded of, that if you're doing any kind of internationalization, it's much better to have a consistent attribute key value pair. And that's probably another thing I should mention that I often do that I didn't this time. Oftentimes, testers ask their devs to add IDs everywhere on the page. I actually recommend people use a data attribute value, so like data-test, and give unique values for a data-test for the element that you're interacting with. The great thing about doing that instead of using IDs is that it provides context for anyone looking at the code to know, oh, there's a test associated with this element that if I change it, it's going to break. And so for people that are using CSS and relying heavily on class names, and then any kind of site redesign happens, they break. Whereas if you've got a data-test attribute, it's less likely that the developers are going to ignore that and change things and break your tests. And so I have to use XPath because there's no IDs or names. If you are not doing some kind of axes going up in the DOM, locating something and then going up or to the left, or locating by text, I guarantee there's a better way to do it in CSS than in XPath. So that shouldn't be the reason that you're using XPath. Yes, XPath in mobile, and again, XPath in mobile is not ideal for many reasons. There are better options than XPath that are much faster, especially in iOS. It's a completely different subject, but take a look at the predicate chain and the class chains. There's ways that you can get the equivalent of most XPath in a way that's much faster for Appium to work with. I get you a link on Appium Pro that walks through that pretty well. All right. As far as the performance between XPath and CSS, there have been a number of tests that have been made over the years, and there hasn't been anything consistent that's really shown a significant difference. It pales in comparison to network bottlenecks and commands between the driver. That should not be the limiting factor in using it or not using it. So I don't like it, but that's not the reason I don't like it. Yeah, exactly. So, all right, I didn't get a follow-up to Angular versus Protractor. Working with single-page apps is difficult, especially because the synchronization becomes really important, making sure things are displayed before you interact with it. IDs are difficult to use with single-page apps because they're supposed to be unique in the DOM. And I seriously have had a number of people say, hey, I'm locating this by the ID and something wrong. It's like, can you just double check and make sure there's not more than one ID on the page? It's like, oh, sure enough. Yeah, I need the second ID of that value. Protractor specifically working with Angular. Protractor was a great solution for Angular JS. It had some some special synchronization magic that happened with it that was really useful. The latest versions of Angular and the latest versions of Protractor don't work that great together always. It depends on the context of the libraries being used, but sometimes that special killer feature actually is detrimental to being successful. Yeah, so there's a number. I can get you a link on some of the downsides of using Protractor right now if you're looking for that. In general, at this point, SAUCELABS recommends using WebDriver IO if you're looking to write your tests in JavaScript, because it is better maintained and it does have some of the additional test logic that is necessary for being successful with your tests. Also, it doesn't hurt that the person who wrote WebDriver IO is a SAUCELABS employee, and so he does a great job of making sure that everything just works with our platform.